discussing about today is trigonometry. Okay, we have trigonometric ratios of 30 degrees, 60 degrees, and 45 degrees. Okay, if you look at the trigonometric ratio, is talking about a triangle. Okay, so when we have a triangle like this, for example, we have our triangle like this. This is what we call equilateral triangle. Okay, so there are three sides equal. It's called that is trigonometry. Okay, so from there, so when we have a triangle like this, so we now have, for example, we know for a equilateral triangle, so what we have all the sides equal, which is what? 60 degree. Here also is what? 60 degree. Okay, now if you have all the angles inside equal, what about the side? The sides will be equal. For example, if you have it to be what? 2, 2, and 2. So from here, what is going to happen here? So we're going to have something clear here, because if we have, if you divide this triangle into two right angle triangle, so we are going to have this be what? A part of right angle triangle, and here to be also another part of right angle triangle. So with that now, we now have two right angle triangle. So now, what are we going to do? If here is 60, what will happen here? We now turn to 30 degree. The angle will turn to 30. Alright? Here also be 30 degree. So in whole, we have 60, 60, and 60. Okay, from there, let's break this triangle. And another thing is that we also have something here called square root of 3. That is root 3. Okay, so I will explain how we get this root 3. Okay, so let's bring out our triangle. Okay. Okay, this is our triangle. So we have 2. Then we have, let me just say we have x. So if here is x, now know when here is 2. So from here to here is 2. So we have 1 here. So we have to have 1 here. So now let's do something here. So if here is 60 degree, is it not? If here is 60, so how can we get our x here? We can only get our x here since it's a triangle, a right angle triangle. Okay, for example, if here is a right angle triangle, and we have something called Pythagoras theorem. Okay, we have Pythagoras theorem that says that the hypotenuse side, which is the longest side, the hypotenuse side equals to what? Opposite side, which is what? Opposite square plus the what? Adjacent square. Where is our hypotenuse? This is the longest side. The longest side is facing the angle 90, which is the right angle. So why this is what the longest side of this one opposite? This one opposite. Okay, and why this one is the adjacent? Okay, now for we to get the value of this now, so that will have what your opposite. The hypotenuse is what? Hypotenuse square, which is 2 square equals to opposite is what? It's x square. That is what we're looking for. Okay, then what x again plus your adjacent is 1. So 1 square. So what I'm going to do? We have 4 equals to what? X square plus 1. Because 1 is what? 2 is what? 1. So from there we let the right hand. So x will have what? Let me just say 4 then minus 1 equals to what? X squared. So from there we have 3 equals to what? X squared. So what will happen? X will now be equals to what? Square root of 3. So that's the reason why we have root 3 here. Okay, so from there now we can now use something called SOH CAH TOA. So there's something called SOH CAH TOA. So with this now we can find all the angles in our triangle. For you to find without using calculator, we find what we call sine 30, sine 60. Then we have a separate triangle for what? For angle 45. Okay, now so let's do for 30 and 60. So we're not going to say in the triangle. Let me name that. Let me name the triangle. Now, for example, we have square root this is 3. Then we now have here to go A, B, and C. So in triangle ABC, in triangle ABC. So we want to find sine. Let's start with sine. So yeah, that is what? Sine. We have 68. Sine 60 degree is equivalent to what? For me to find sine 60. So let's look at what says what? Opposite over hypotenuse. Where's our opposite? These are our opposite. This is the angle we are talking about with 60 degree. See, and 60 is facing here. That is what your opposite is now 3 then over hypotenuse. So hypotenuse is what? 2. So this is what sine 60 is what? 3 over here we have our adjacent. So now the sign has changed, the triangle has changed. So now let's go. I want to find sine 30 degrees. So we're going to have what? So, which is what? Opposite over. Where is our opposite? This is our opposite. That is what? Opposite is 1 and over what? Adjacent. Where is our adjacent? Is still what? 2. So what again? So when we have cos 30 degrees, don't forget 30 degrees. So what are we going to have? We are looking for cos, which is adjacent. Where is our adjacent? Adjacent is here. That's what? Root 3 over what? Adjacent is root 3 over what? Hypotenuse, which is 2. Okay, so we'll go for tan. So tan 30 degrees will now be equivalent to what? So what we have here? We're going to have tan over 12. So that is what? Tan 30 will now be what? Where is our opposite? This is our opposite, which is still what? 1, then over what? Then adjacent is what? Root 3. So we have root 3. Okay, so this is the equivalent of all the sines angle. So from there, let's go for angle 45. Angle 45. So capture this and let's go for angle 45. So before we now be able to solve. Okay. So let's go for angle 45. So angle 45 we take a right angle triangle. Okay. So here is our 90 degree angle. I know this is a right angle triangle. So we can have our angle 45 to be here. Here can be angle 45. Here to can be angle 45. So we now have something called here will be 1 and here will be what? Root 2. Then here is what? 1. Okay. So this is what we have for angle 45. Okay, how do we get root 2? So when we have our triangle like this, so using our Pythagoras theorem, so if here is what? 1, and here is 1, and here is 1. So what are we going to do? So we're not going to say, hypotenuse square equals to what? Using Pythagoras theorem. So what are we going to have? Then opposite square plus what? Adjacent square. So from there we're going to see our hypotenuse is what? Is 1 square, then equivalent to what? Let me say here's x, sorry, here's x. So that will have be what? X squared, because we're looking for x. I want to prove how we get square root of 2. So equals to what? Opposite is what? Opposite. If here is 45, opposite is what? This is always our opposite. It's yes, that is what? 1 square, then plus what? Adjacent is what? Or adjacent is still 1 square. So what have it together? S square equals to what? 1 square is still 1 plus 1. Then x is now equals to what? S square equals to what? 2. Then x is now equals to what? Square root of what? 2. So that is how we get our square root here. So now let's now use it to what? To solve. So now, don't forget your SOH CAH TOA. Okay, again, let's go for tan 45. So tan 45 will now give us what? So in triangle ABC, let's go again. Here's our triangle A, B, and C. So what do we have here now? For tan, that would be what? Sine 45 equivalent to what? So it's what? Opposite. Where's our opposite here? This is our opposite, which is what? 1, then over what? Where's our hypotenuse? Is what? Is 2. Hypotenuse is root 2. So we go for another one, which is what? Cos 45 degree, which is what? Cos 45 is what? Adjacent. Where's our adjacent here? This is our opposite. Okay, this is what? Hypotenuse, and this is adjacent. Okay, so our adjacent is what? 1 over what? That is 1 over what? Hypotenuse, which is what? Root 2. So what do we have now? We have tan 45 degree. Tan 45 degree will now give us what?